Hey guys, it's Miss Fendley. Hope you guys all had a lovely break and a happy new year. I'm bummed that I'm not there with y'all right now, but I am really genuinely looking forward to getting back and seeing y'all next week. Um, I'm doing well. Everything's healing up pretty nicely, but I will see you guys soon. Remember, how you behave represents me, and I would really like to be able to bring you cookies on Monday. Um, all right, so we're going to go ahead and jump into Chapter 9. So, Chapter 9 is right angles and trigonometry. It is just the very intro, kind of getting your toes wet on trig. And section 9.1 is the Pythagorean Theorem. So, we have used the Pythagorean Theorem a lot before. I know you used it we've used it in this class. You learned it in Algebra 1. I think maybe you saw it in middle school at some point. Excuse me. But we've always used it for right angles. So today we're going to actually look at how we can use it. We're going to look at using it for right angles, but we're also going to look at how you can apply the Pythagorean theorem to acute angles and obtuse angles also. So the Pythagorean theorem is named after a dude named Pythagoras. He was an ancient Greek philosopher and mathematician. According to these pictures, he had a pretty awesome beard. He did not actually invent the Pythagorean theorem, which seems a little cheaty, but he was the first guy that proved it. So you know how much you love proofs, what we did in chapter 2 with all that. Yeah, they've been doing proofs, math proofs, for at least 3,000 years. So keeping history going, friends. And the Pythagorean theorem is probably one of the most famous theorems in all of math. So, see, I think I've got a couple of pictures. So we're going to go on and then we'll come back to that little thing about, hey, look at this GIF. We'll come back to it in a second. So in a right triangle, this is just kind of review. In a right triangle, the longest side, which is the side opposite or across from the right angle, is called the hypotenuse. Right? Hypotenuse. And then the other two sides are called the legs. Okay. So hypotenuse is the most important side, the longest side, the side across from the 90-degree angle, and then the other two sides are called the legs. So in formal academic vocabulary, the Pythagorean theorem says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Okay, so in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So make sure you get that down, and we'll talk about what that means. Okay. And in equation form, we say that is c squared equals a squared plus b squared. So remember, In middle school, you probably learned it as a squared or a squared plus b squared equals c squared. And when we started this year, I said I really want you to start getting in the habit of putting the c squared first. This chapter is, you're going to see why we want to be in the habit of saying c squared equals a squared plus b squared. Okay, so make sure you've got that written down, and then go ahead and flip your paper over. Okay, so on the back here, these are just a couple of illustrations. I know yours probably printed off really dark. I apologize. I wish I could print it in color. Excuse me, guys. This top picture, so you have 3 squares. I'm going to call the red square, let's call that square A. Then we got square B and square C. So if you make a triangle, you've got this right angle triangle here, yeah? So if you make a square on each of the sides, this has the side length of that side, right? So remember, on a square, all 4 sides are the same. So if this is 4 units long, then this is also 4 units long, right? So if you make the square with all those sides, do the same thing on B. So say this was 3 units long, this is 3 units long. Then this square, C, would be whatever 3 squared, or C squared, the square with side length C, is equal to 3 squared plus 4 squared, or A squared plus B squared. And this picture down below it is another visual of that. So I'm going to come back up here and follow this link, because it actually has a little diagram that shows you how you can make a, oh gosh, never mind. Okay, so you've got all of, oh, I can't draw on this one, that's a bummer. But you've got these squares with side lengths A, B, and C, or excuse me, the triangles with sides A, B, and C, that when you move them around, you can see that the squares of A squared and B squared are the same as the area of C squared. My favorite demonstration of the Pythagorean theorem is actually this water demo. So here we have, actually I'll just let them play it. Okay, so if you've got squares A and B, that the area of square A and B is equal to the area of square C. So that's C squared, and let her turn it over. C squared now is equal to A squared plus B squared. So this right here is by far my favorite demonstration of how the Pythagorean theorem works. All right, so A squared plus B squared equals C squared. C squared equals A squared plus B squared. All right, so let's jump back over to the notes. Okay. All right. So we looked at our little demonstrations here. So in this example, I was like, okay, well, 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. The square root of 25 is 5. So this side would be 5. In this case, you have a right triangle where all 3 sides are whole numbers. And that's not super common. So when that happens, we call that a Pythagorean triple. So a Pythagorean triple. And a Pythagorean triple is a set of 3 positive integers and remember, integers just mean, in this case, when we're talking about positive integers, we're talking about whole numbers. So like 1, 2, 3, 4, 5. So not 1.4 or 1/3. So whole numbers that are positive in this case. A, B, and C that satisfy the equation c squared equals a squared plus b squared. So in less fancy terms, a Pythagorean triple is numbers that work out in c squared equals a squared plus b squared so that all three of the numbers are whole numbers. And this here, the common Pythagorean triples and some of their multiples, these are just numbers that, like the most common ones that you will see. More exist, but these are some of the smaller numbers that you'll see fairly often, especially like the 3, 4, 5, 5, 12, 13, 8, 6, 8, 10. Like you'll see those pretty often whenever we're trying to do something with the Pythagorean theorem and don't really want to deal with fractions or decimals. These are the numbers that we end up using as examples a lot. All right, so let's go on down to the next page, or flip on over, excuse me. Okay, so on example 1, it says find the value of x, then tell whether the side lengths form a Pythagorean triple. Okay, so when it says to find the value of x, we see here, hey, that's a right angle right there. We got that little red square, and we know that if we have a right angle, then c squared equals a squared plus b squared. Okay? And we know that c squared is the longest side, the hypotenuse. It's also the side across from the right angle. So in this case, x is going to be our c value. A and b are the legs, so it doesn't matter which one is which. Okay? So c squared is x squared equals a squared plus b squared. I'm going to say 5 squared plus 12 squared. All right, take a moment. Ask your neighbor, what's 5 squared? Good job, it's 25. And ask your neighbor, what's 12 squared? Good job, guys, that's 144. All right, and then 25 plus 144 is, I'm pretty sure I know this one. Hang on, I think it's 169, but I'm going to double check because my brain's not functioning at full speed right now. Yep, it is. It's 169. All right, equals 169. And then does anybody know off the top of their head what the square root of 169 is? All right, good job, folks. The square root of 169 is 13. All right, so side A is 5 units, side B is 12 units, and side C is 13 units. So we found the value of x, that was the first instruction, and then it says to tell whether the side lengths form a Pythagorean triple, so do they? Yeah, 5, 12, 13, those are all whole numbers, so yeah, it is a Pythagorean triple. I'm going to put yes. Pythagorean triples. Or yes. Yes, it is a Pythagorean triple. All right, you guys go ahead and do the U-try. Find the value of x, then tell whether the side lengths form a Pythagorean triple. I'm going to give you, let's say, how long do we do? 2 minutes? 1.5? Let's do 1.5 minutes. Go for it. 30 seconds, guys. Okay. Oh, that's an annoying sound. All right. So I'm going to walk through this real fast. I'm sure you guys got this pretty quick. But we've got x as our hypotenuse. So x squared equals 4 squared plus 5 squared. Okay. So c squared equals a squared plus b squared, remember? I'm going to write that down if we need to. A squared plus b squared. All right, so 4 squared is 16. 5 squared is 25. 16 plus 25 is 31. I think, let me double check. Now my brain is just slowed it. Oops, 41. Good thing I checked. Oh man. My brain is just running slow right now. Okay, so x squared equals 41. Alright, so then we take the square root of both sides. So the square root of 41 is about 6.4. Okay, it's about 6.4 units long. So not a Pythagorean triple. So we found the value of x, but that is not a whole number. So not a Pythagorean triple. All right. So Pythagorean triple just means all three numbers are whole numbers. That's really it. Okay. All right. So going to jump back to chapter 2 in our brains. The Pythagorean theorem says that if a triangle is a right triangle, then c squared equals a squared plus b squared. Going back to chapter 2, the converse of the Pythagorean theorem is also true. So remember, the converse means we had swap, negated, swapped, and negated. Converse means swapped. So if you have a triangle and c squared equals a squared plus b squared, then you know that that triangle is a right triangle. So let's look at this first example. Okay, it says tell whether each triangle is a right triangle. Okay, so remember, C is always going to be your longest side. Okay, so we got the square root of 113. If you plug that in your calculator, excuse me, you're going to get something like 10.6 something. And that is longer than 8 and 7. So, and also visually, you can tell that this is your longest side. So right now we're checking, is c squared equal to a squared plus b squared? So I'm going to put that little question mark. Are they equal? So c is the square root of 113. So the square root of 113 squared equals 8 squared plus 7 squared, a squared plus b squared. Remember, a and b don't matter which one is which. Okay, now before you jump into this and start freaking out of, oh, the square root of 113 squared, how do you do that? Remember, square roots and squares, they're inverse operations. They cancel each other out. So the square root squared actually cancels out, and you don't even have to use a calculator for that. The square root of 113 squared is just 113, right? Equals 8 squared, which is 64. 7 squared is 49. And 64 plus 49 is 113. So this whole time we've been checking, are these equal? And they are, in fact, equal. So, yes. It is a right triangle. It is not a Pythagorean triple, but it is a right triangle. All right, so you guys take another 2 minutes, or 1.5 minutes. Let's do 1.5, and do the U-try. Should I? No, I'm gonna let you guys see if you can figure out that 4 squared of 95. Actually, I'll give you 15 seconds on that, and then I'll go over it, okay? Okay, so I know you're not finished, and I'm not going to go over the whole thing yet, but I do want to, let's address this 4 square root of 95. Visually, you can tell that that is your longest side, so that's going to be your C of our C squared. Is C squared equal to A squared plus B squared? Okay, so when we plug in 4 square root of 95 squared equals 15 squared plus 36 squared. Because we are multiplying, we can actually separate that. That can be 4 squared times the square root of 95 squared. And I know that I'm not maybe explaining that as slow as I could, but when you're multiplying things, it's not exactly distributing, but it's kind of the same, that when they're being multiplied together, excuse me, the square goes with each of them separately. All right, so 4 squared is 16, and 95 squared, or the square root of 95 squared, remember the square and square root cancel out, so we're just left with the 95. So on the left side, we have 16 times 95, okay? So I'm going to give you another little over a minute to finish that problem up, and then I'll come back and we'll go over it. All right, 30 seconds. Okay. All right. So I really should just get a normal calculator instead of using my computer right now. But 15 squared, I believe, is 225. Yep, 225. Yeah. And 36 squared is 1,296. Okay. So I'm just going to kind of skip this step and say 16 times 95 is 1,520. We're checking to see, are these equal? And 225 plus 1,296 is 1,521. So those are not equal. So this is a triangle, but it is not a right triangle. So on these questions, when it says tell whether each triangle is a right triangle, all you're doing is plugging the numbers into the Pythagorean theorem. Use the biggest number for C, and then if it works out and makes an equation that works, then yes, it's a right angle. If it gives you two numbers that are not equal, then it's not a right triangle. That's how the converse to the Pythagorean theorem works. All right, take a moment, take a breath, and then flip over. Make sure everybody's got this down. And then we're going to look at the triangle inequality theorem. All right, flip on over. Excuse me, guys. All right, the triangle inequality theorem. All right, we're getting near the end because I'm not 100% certain that my voice is going to last much longer, but we're getting close to the end. All right, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the third side. So what does the word sum mean? Right. Sum means the answer you get when you add two numbers together, right? So if you add two sides together, it's going to be longer than the third side. That's what the triangle inequality theorem says. And I wonder if I can show you, because let me show you what happens if you don't. So let's say you have these two little sticks, right? And you've got the third side that's really long. If you tried to put these little sticks together to make a triangle, why is it not circling? Okay, you try to put these little sticks together to make a triangle. That's not going to make one triangle, right? You got like half of the stick or one of the sides hanging off. So the two shorter sides together, no matter how long the third side is, the two sides together have to be longer than it so that the triangle can close at the ends of the points. All right. All right, then the Pythagorean inequalities theorem. This is why we've taken so much, like I've been saying, hey guys, put the c squared on the left side. So the Pythagorean theorem, right? The Pythagorean theorem, I'm going to write this up here, says that if a triangle is a right triangle, then c squared equals a squared plus b squared. Or if c squared equals a squared plus b squared, then we know that the triangle is a right triangle. The Pythagorean inequalities theorem says for any triangle ABC where c is the length of the longest sides, the following statements are true. Highlight these or underline them, do something. If c squared is less than a squared plus b squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. If c squared equals a squared plus b squared, then it is a right triangle. Okay? And remember, c is always, always, always the longest side of the triangle. All right? So let's look at this first example. It says, verify that, so you've got, let's say you've got 3 sticks. Okay, you're out in the wood and you pick up 3 sticks. The first stick is 4.3 feet, the second one is 5.2 feet, and the third one is 6.4 or 6.1 feet. Verify that you can make a triangle out of these, and then if you can, is that triangle acute, right, or obtuse? So first thing I'm going to do is use the triangle inequality theorem that says if I take the two shortest sides of the triangle, 4.3 plus 5.2, they have to be longer than the third side of the triangle. Well, that's going to be 9.5. 9.5 is greater than the longest side of the triangle. So the two shortest sides together are longer than the third side. So yes, it will form a triangle. Or they will form a triangle, would probably be better grammar. And then what type? So c squared, is it going to be equal to a squared plus b squared, less than it, or greater than it? Okay, a squared plus b squared. So I like to put that little box there because I'm going to plug in c, a, and b, and then I'm going to figure out, is it less than it, equal to it, or greater than it? Okay, so c is the longest side, which is 6.1 in this case. Okay, so 6.1 squared is something, less than, equal to, or greater than a squared plus b squared, so 4.3 squared plus 5.2 squared. All right, then I'm just going to plug these in my calculator. So 6.1 squared is 37.21. Again, I don't know what's going to go in there. 4.3 squared is 18.49. And 5.2 squared is 27.04. Okay. So bring down the left side, the box, and then 18.49 plus 27.04 is 45.53. 45.53. So since 37.21 is less than 57, or excuse me, 45, oh goodness, 0.53. It's less than it, right? We know that if you were to make a triangle out of these lengths, it would be an acute triangle. So these side lengths will form an acute triangle. All right. So you guys go ahead and do the U-try in just a second. It says verify that the lengths of 3, 4, and 6 will form a triangle. So, add the two shortest sides together. Are they longer than your third side? If they do, then go on to the second question. Is the triangle acute, right, or obtuse? So basically, the first question is, God, I don't want to confuse you more with this. The first question says, is c greater than a plus b? If that question is yes, then we go on to the second question that says c squared is what? Then a squared plus b squared. Okay? All right. So you guys do the U-try. Let's see, let's do a minute and a half. That seems good. Go for it. Oh, I forgot to hit start on that timer. Sorry. If you need another second, you can pause the video, but I'm going to go ahead and go over it. So, first question is 3 plus 4. Well, 3 plus 4 is 7. 7 is greater than 6, so yes, it will form a triangle. Okay. Then the second question, what type of triangle? So I'm going to use 6 as my c. So c squared, so 6 squared is something. 3 squared plus 4 squared. Well, 6 squared is 36. 3 squared is 9. 4 squared is 16. Okay. And then 9 plus 16 is 25. So 36 is greater than 25. And notice if c squared is greater than a squared plus b squared, this is an obtuse triangle. All right. And then we'll just kind of go through this last one together really fast. Verify that that segments with the lengths of 2.1, 2.8, and 3.5 will form a triangle. So 2.1 plus 2.8 is 4.9. 4.9 is greater than 3.5. All right, so yes, it will form a triangle. And then is c squared is what then? A squared plus b squared. The longest side, so is c, so 3.5 squared is something then 2.1 squared plus 2.8 squared. All right, so I didn't write these answers down ahead of time. That's a bummer. All right, so 3.5 squared is 12.25. All right, 12.25. 2.1 squared is 4.41. And 2.8 squared is 7.84. Okay. So 12, we're going to bring down 12.25. And then 4.41 plus 7.84 is 12.25. Well, 12.25 is equal to 12.25. So since c squared equals a squared plus b squared, this will be a right triangle. All right. So this is pretty much it for chapter 1. It's the Pythagorean Theorem, which you've been doing since sometime in middle school, and then you recovered it in Algebra 1. We recovered it several times this year. The Pythagorean Theorem itself says c squared equals a squared plus b squared. And if it's not equals, if c squared doesn't equal a squared plus b squared, then that actually tells us whether the triangle is obtuse or acute. And remember that an acute triangle has 3 acute angles. An obtuse triangle has 1 obtuse angle. Hopefully everything makes sense. I'll, of course, explain it next week when I get back. Text me on Remind if you have questions, not during class time. That is not permission to get your phones out. But I hope that you guys are having a lovely day. Make sure you get your homework done. Fourth period, be quiet, do your work. Please let me bring you cookies instead of quizzes. And I will see y'all soon. All right, bye.